Alright guys, for semester 2 practice we've got a handful of topics for Monday and Tuesday, the 13th and 14th of April. So we're going to review a couple of things. So there's a funny way they ask you to solve one-step equations, we'll talk about that. Finding slope using 2 points, you all know how to do that, but we're going to review that. And then we're also going to talk about some more probability stuff, which you should be doing in your algebra class. So let's go ahead and jump right in. So first, they have kind of a funny way, and you're going to see this in your homework assignment, of they've given you a one-step equation and they're asking you to find out whether these numbers are a solution. So the simplest way to solve something like 41 equals 34 plus w, you guys know, is just to subtract 34 from both sides, and the answer is going to be, of course, 7. The way that they will explain it on ALEKS is if you replace w with 10, you do 34 plus 10, and then we're checking, does 44 equal 41? No, that's false. So you'd click no right here. And then you try that with all the other ones, and you'd find out that 7 is the only one. Sometimes you won't get any that are correct. So w equals 10 is not a solution. The only one that will work here is w equals 7. So it shows you the possible answers right here. Now, of course, you don't need to go through all that trouble. There's only going to be one correct answer on an equation like this, so you can simply solve the equation and click yes to the correct one and no to all the false ones. So you might see one like this as well. This will show up on your homework assignment, solving a variable in terms of other variables. So here we're not actually getting an answer where like a equals 10 or x equals 3. Instead, we're going to solve for one equation, or one variable, I should say, in terms of another. So in this one, it says solve for b, and you'll notice that there's the variable b and the variable a. We're going to use the same basic rules of algebra. We want to get b all alone, as if we were solving for it. So in order to do that, you guys can see you're just going to add 16 to both sides. And the 16s cancel on the left. We have 16 on the right. And we end here. It's kind of weird, but we end with our answer is b equals a plus 16. So it might feel a little unusual to end your problem there, but we're just trying to isolate or solve for a single variable where there's other variables involved. So here's a couple other examples, or another example, I should say. So we have y over 4 equals x, and you guys know how to solve this for y. You simply solve by multiplying by the denominator, 4. So 4 times 1 over 4 cancels out, and then on this side you have 4 times x, so you get y equals 4x, and you just stop there. It's kind of like when you're solving an equation, putting it into slope-intercept form, so nothing too bad there. Okay. Quick review, you guys know how to use the slope formula to solve for slope. So we've got 2 points here. It doesn't really matter which one you pick to be x1, y1, x2, and y2. I like to go x1, y1, x2, y2. And then you just plug those in. In this case, we've got y2 plugged in right here, y1 plugged in right here, and so on. And don't forget to simplify. So on the top we've got 6, on the bottom we've got 8. Divide both top and bottom by 2, you get 3/4. So just a quick review, should be pretty straightforward to do that. Now a couple other things to do with probability that you've probably seen so far. I want to go back through those talking about a tree diagram. So you don't actually have to make these necessarily to calculate probabilities, but it's good to see, it's good to interpret and practice with one of these tree diagrams. So here we have a class is choosing a president, a vice president, and a treasurer, like a student government, for example. So there's 3 students, Anna, Maria, and Linda, running for president, 2, John and Bob, running for vice president, and 2 students running for treasurer, Jessica and Amanda. So you guys know, using the counting principle, we could figure out how many different combinations of elected people you could have. That's also well represented in a tree diagram. So we start with people that could be president. There are 1, 2, 3 of them. So let's say you've picked Anne to be your president, and we want to have a full cast of characters. So if you picked Anne, now you have 2 choices for John, or 2 choices for vice president, John or Bob. And then let's just say you go and pick Anne and John. Now that you have those 2, you can pick from 2 treasurers, so Jessica or Amanda. So if you picked Jessica, your combination there would be Anne, John, and Jessica. If you went any other combination, you could have these other 12 or other 11 outcomes. So question A is, how many outcomes are there? If you just count, there are 12 outcomes. How many outcomes have both John and Jessica being chosen? So if you look through the list, you need both John and Jessica. So the first one right there, this middle one right here, and this one right there. There are a total of 3 of those. And how many don't have Linda? If you look through the list, there are 4 that include Linda, and those would be the ones that start right here. None of these can have Linda because after you pick a president, she can't be in there. So these 4 have Linda, so 8, the remaining 8 do not have Linda as an outcome. So you can do a lot of this with just pure numbers, but here you're seeing it drawn out in a tree diagram. Reviewing quickly the counting principle, if there's a lunch special at Lucy's restaurant, you can have a sandwich, a drink, and a dessert. There are 6 sandwiches to choose from, 2 drinks, and just the 1 dessert. How many lunch specials could you possibly have? So if you wanted to go crazy and order every single different possible lunch special, you'd get to pick from 6 sandwiches, and then you'd multiply that by the 2 drinks you could have, and then you only have 1 dessert. So 6 times 2 times 1, that equals 12. So there's 12 possible lunch specials. So if you've ever gone to like an ice cream shop and it says, over 1,000 flavor combinations, they're probably talking about the ice creams and the toppings that you can pick from, and they've done the counting principle and multiplied them all together to get more than 1,000. So here's another example. You might see one like this where you're ordering a kid's lunch at a restaurant called Burger Universe, and the customer has to choose a size, whether or not to have cheese, type of bun, side order, and type of fruit snack. So basically, we're going to use the counting principle to find out how many kids' lunches are possible, and you'll just count the number of options you have at each step. So for size, there are 1, 2 choices. For cheese, there are 1, 2 choices. For bun, 1, 2 choices. Side order, 1, 2, 3, 4 choices. And for fruit drink, there are 2 choices. So if you multiply all of those together, 2 times 2 times 2 times 4 times 2, you get 64 possible lunch choices. And if you change the number of any of these, the size, the cheese, and so on, that would either increase or decrease the number of possible kids' lunches you could have. All right, so the last thing I want to talk about is something called permutations, which is going to help us on our last question here. So you've been talking about ordering and combinations and things like that. So we want to talk about what's called a permutation. That's where we're ordering the number of items that we have. So for example, if we have 16 pool balls, how many different orders could we put them in? What we mean there is take, ball number 16 and put it first, and then take any other ball and put it second, take any other ball and put it third, and so on. So after you choose, let's say you're going to take the number 14 ball and put it first, you can't choose it again. So instead of having 16 pool balls left to choose from, you'll only have 15 pool balls to choose from. And so as you can see, our first choice has 16 possibilities, the next choice has 14, then 13, and so on and so on and so on. So you just multiply the number of choices you have at each step. You could imagine taking 1 ball at each step. So if you go 16 all the way down times 15 times 14 and so on all the way down times 1, you get this huge number, something like 20 trillion options of ways you could order that set of balls. So here you had 16 total, and you're choosing all 16 of them and ordering them. And again, you have over 20 trillion options. But let's say that we just chose 3 of them. So we would say that the total number is 16, but we're just choosing 3 of them. You're going to see this N total and K choices coming up here in a second. So there on our first choice, we have 16 balls we can choose from. So you'll have 16 times the next choice. You just have 15 remaining, so times 15. And then your next choice times 14. And then we stop there because we only wanted to pick 3 pool balls. So if you do 16 times 15 times 14, you end up with 3,360 choices. So you can see many fewer because we're not doing all that multiplication. Okay, so with that in mind, we're going to use permutations to help us solve a combination question. So Mary has 7 CDs and she's going to give them away. She lets her best friend choose 2 of the 7 CDs. How many different groups of 2 CDs are possible? So we're counting groups here. A group is the same no matter how the members are listed. So if her friend picked CD1 and CD2, that's the same as if she had picked CD2 and CD1. So we're first finding combinations. We use the following formula. So the number of combinations of n things taken to k times. So there's 7 balls and we have k choices. We're going to first do the number of permutations of 7 things, n things, taken k2 at a time. That's what we just reviewed a moment ago. Remember, we had 16 things and we chose 3 of them. Okay, and we're going to divide that by the number of ways of ordering k things. So if you think about it, there's only 2 different ways we can order it. We could order it 1, 2 or 2, 1 for CDs. So to actually plug all that in, the number of combinations of 7 CDs picked 2, her friend is picking 2, the number of permutations would just be 7 times 6, because the first time there's 7 CDs laid out in front of her, she can pick any one of those 7. Now that she's removed one and picked it, she only has 6 choices. So we'll do, for the top number, the number of permutations. That'll be 7 times 6. And then on the bottom, there's only 2 ways we can order 2 CDs. So we do 7 times 6 on the top, divided by 2 times 1 on the bottom. 42 divided by 2, that's 21. So hopefully that helps you guys understand how to do the various problems for today's practice. Please, please, please reach out if you have any questions about how to solve any of these. Thanks so much.